Now we talk about general differentiation. As introduced in the previous chapter, the derivative of a function y equal to fx is defined as dy by dx is equal to limit delta x tends to 0 f of x plus delta x minus fx upon delta x, or limit h tends to 0 f of x plus h minus fx upon h, whether delta x is positive or negative, must be unique. It is also denoted as f dash x or d by dx of fx. In this chapter, we assume that the derivative exists, and those points where the derivative does not exist, those points will not be considered in the domain of the derivable function. Thus, we confine ourselves to the derivative of functions only. We give below some standard formulas for derivatives. We may not derive their derivatives, and hope you'll do them yourself. First, the derivative of x raised power n is equal to nx raised power n minus 1. If we replace x by fx, d by dx of fx raised to power n becomes n into fx raised to power n minus 1 into d by dx of fx. Similarly, d by dx of ax plus b raised to power n becomes n into ax plus b raised to power n minus 1 into a. Second, d by dx of sin x becomes cos x, or d by dx of sin of fx becomes cos of fx into d by dx of fx. Third, d by dx of cos x, that is the derivative of cos x, is minus sin x. That implies d by dx of cos of log x, cos of fx, is equal to minus sin of fx into d by dx of fx. Fourth, the derivative of tangent x is equal to secant square x. Therefore, derivative of tangent of fx becomes secant square of fx into d by dx of fx. Fifth, the derivative of cot x becomes minus cosec square x. That is, d by dx of cot of fx becomes minus cosec square of fx into d by dx of fx. Sixth, the derivative of secant x becomes secant x into tangent x. That shows d by dx of secant of fx is equal to sec fx into tangent fx into d by dx of fx. Seventh, the derivative of cosec x becomes minus cosec x into cot x. That is, d by dx of cosec of fx is equal to minus cosec of fx into cot of fx into d by dx of fx. Now the derivative of sine inverse x becomes 1 upon square root of 1 minus x square, where mod x is less than 1. Therefore, d by dx of sine inverse fx will become minus 1 upon square root of 1 minus fx square into d by dx of fx whenever modulus of fx is less than 1. 9. The derivative of cos inverse x becomes minus 1 upon square root of 1 minus x square for mod x is less than 1. This shows d by dx of cos inverse of fx becomes minus 1 upon square root of 1 minus fx square into d by dx of fx whenever mod fx is less than 1. 10th, d by dx of tangent inverse x is equal to 1 upon 1 plus x square, x belong to R. Therefore, d by dx of tangent inverse of fx is equal to minus 1 upon 1 plus fx whole square into d by dx of fx. Fx can have any value. 11th is d by dx of cot inverse x is minus 1 upon 1 plus x square. X belongs to R. Therefore, d by dx of cot inverse of fx is equal to minus 1 upon 1 plus fx whole square into d by dx of fx. Fx belongs to R. 12th, d by dx of sec inverse x is equal to 1 upon modulus of x into square root of x square minus 1 mod x is greater than 1. This shows d by dx of sec inverse fx is equal to 1 upon modulus of fx into square root of fx square minus 1 into d by dx of fx whenever modulus of fx is greater than 1. 13th, d by dx of cosec inverse x is similarly minus 1 upon mod of x into square root of x square minus 1 whenever mod x is greater than 1. This means d by dx of cosec inverse of fx is equal to minus 1 upon mod of fx into square root of fx square minus 1 in the denominator multiplied by d by dx of fx whenever fx is greater than mod fx is greater than 1. 14th, d by dx of e raised power x is equal to e raised power x. That means d by dx of e raised power fx is equal to e raised power fx into d by dx of fx. 15th, d by dx of a raised power x becomes a raised power x into log of a to the base e. A is positive. Similarly, d by dx of a raised power fx becomes a raised power fx into log of a to the base e into d by dx of fx. 16th, d by dx of log of x to the base e of course is equal to 1 upon x. That means d by dx of log of fx to the base e is equal to 1 upon fx into d by dx of fx. 17th, d by dx of log x to the base a is equal to 1 upon x times log of a to the base e in the denominator. That shows d by dx of log of fx to the base a is 1 upon fx into log of a to the base e in the denominator into d by dx of fx.